Alright, so now we're going to move on to number 5, which actually is working backwards, I know, but that's alright. So this is a right-tailed test where sigma equals 1.8 and n equals 18. So what I'm going to do is I'm going to copy all the pertinent stuff, basically this top portion. And I'm going to go make a new page, sheet 11. I'm going to call it 10.5 number 5. I'm going to paste this in. Alright, so we saw that this was 1.8 and this was 18, I believe. Oops, wrong thing. Yeah, 1.8, 18. Let's go to the next page for the rest of the info. S is 2.4 and alpha is 1.10. Here, let me make this smaller so I can see it. Alright, S was 2.4. Hey, look at that, S squared got figured automatically. Nice. And N equals 18, so degrees of freedom was figured out automatically. The only thing we do have to change is alpha. Alpha is 0.10 now. 0.1. Alright, now the critical value. The critical value is not alpha, 1 minus alpha, excuse me. It's now alpha. Okay, so that changes how it gets calculated. It's chi inverse of, instead of 1 minus b over 2, it's just going to be b over 2. Okay, it's going to be a bigger number. And that's because this is a right-tailed test, right? So the 1 minus portion, if you do 1 minus b over b2, excuse me, that's a left-tailed. If you just do regular old b2, that's a right-tailed. All right, now the chi-square statistic, that actually doesn't change. So this is still the same formula. So you take b6, which is your degrees of freedom, n minus 1, times s squared, right, 2.4 squared, or hey, you just move it to 5.76, that'll work too, divided by b1 squared. Okay, beautiful. Then the p-value. Now the p-value is no longer 1 minus chi dist, it's actually just chi dist, right, because it's a right-tailed test. That's how it's going to work for this one. All right, now are we going to reject or not? Let's see here. Oh yeah, we're rejecting. Look, our test statistic is 30. We would have accepted anywhere up to 24.7. But since we're past that, we are rejecting. Okay? But it's not because it's lower than the critical value. It's because it's higher. Right? You're talking about a right-tailed test. So what concerns you is the test statistic being higher than the critical value. Right? But the p-value method always looks at lower than, always. So if your probability of being at 24.7 is super low, i.e. 0.0248, right? If that's less than alpha, you are rejecting, which we are. So just to reiterate, p-value is always easier because p-value always looks at less than. Fabulous, wonderful, marvelous. Now, next time we will look at a two-tailed test, possibly with data.